You know, you've probably heard of horsepower, but believe it or not, this is bug power. This little motor is being powered by the battery here, and inside the battery are living bugs which look like this. These are microbes, they're tiny creatures such as baker's yeast or bacteria. So what's going on? Well, here I've got a test tube containing some of these bugs in water. These bugs are actually called Proteus vulgaris. Now, in this beaker, there's a special chemical called a mediator, which you can see is a bluey-purple colour. Now, watch what happens here. First of all, I'm going to give the bugs some breakfast. And what bugs like for breakfast is a bit of sugar. There we go. Go on, wake up, Proteus, here it comes. Right, they're going to start eating that sugar, and I'm going to put in some of this mediator. Let's squirt it in. Wham! There we are. Everything goes purple. Put the top on and give it a bit of a shake up. And like I said, the bugs are eating away at the sugar and they're producing electrons. These electrons are then captured by the mediator, and the electrons then react with it, and it causes the mediator slowly but surely to change colour. There, can you see the purple bluey colours disappearing and the liquid's going back to its former shade? But how can we use all that as a battery? See, at the moment, this test tube is all charged up with electrons that have got nowhere to go. So you need to draw off the electrons and run them round the circuit. Now, it's quite clever how that's done. Let me just lose you for a second. A battery has two halves to it, and this is one half. It's like a little perspex tray, and you put the mixture in, of your bug mixture, round here on the outside. So that's all producing electrons, and they're picked up by this carbon electrode here, and the electrons come out of the wire at the top here. Now, the other side of the battery is a very similar looking tray, but you don't put the bug mixture around there. You put in some of this yellow liquid, and that accepts the electrons that are coming down that wire and coming out of that electrode. So you put the two halves of the battery together with this piece of special plastic membrane in between them. That stops the liquids all getting mixed up. And there you are, one battery. Now this one hasn't got the liquids in, of course, but here's one that's been made up. In fact, there's three of them in a row there, all set to go. There, you can see it's very similar. Right, let's plug it back into our motor and see if it's still working. Yeah, there we go. Right, so the bug battery, how it works is the bugs are eating this sugar and making electrons. The mediator takes the electrons away from the bugs and pushes them out at the electrode here. The electrons then flow down this black wire, through the motor, which is then turning round, back up the red wire, and then to the other side of the battery. That's pretty simple. In fact, it's not even difficult to make one of these yourself. You could try experimenting with different bugs, but make sure you only use safe ones, well, like this stuff, which is baker's yeast.
Ever seen lightning in a goldfish bowl? This is called a plasma globe, and that thing in the middle is giving off very high-frequency radio waves, a bit like Radio 1, really. Now, inside the globe, there's just a small amount of gas, and it's the radio waves that are making the gas glow like that, and you can get some pretty weird effects. Look at this. Now, Katie, you've got a good effect, haven't you?
Yes, with this tube.
Now, that's just an ordinary fluorescent tube, nothing attached at either end.
That's right. If I place my hand on the globe...
And that's all the energy from the radio waves going into your hand?
Yes, that's right. And you slide your hand slowly up the tube.
Like that.
You can see it gradually lights up.
It's really switched on. And I slide it back and I'll switch it off again. That's very good, thanks. I want one of these.
Here's an unusual motor. It looks like a bicycle wheel, but that's not surprising because it is a bicycle wheel. But these here are iron bolts. Down at the bottom, this is a coil connected to a battery through this, which is a contact up at the top. Now, all electric motors use magnetism, so if I give this one a little start, see if it can work out how this one goes.
Tired of getting pushed around.
If you're wondering what this weird and wonderful machine is, the man with the answers is Bill Church. What's it doing?
It's a high voltage electrostatic generator, a Van de Graaff generator.
And how does it work?
Well, you may have come across the effect of rubbing a comb through your hair or of rubbing a piece of plastic with a handkerchief and using it to pick up little pieces of paper or make your hair stand on end.
Now, it looks like you've turned it into a magnet, but you haven't, have you?
No, we've put a charge on it, an electrostatic charge.
And that's exactly what's happening over here, isn't it?
Yes, except that here we're very lucky because we have an electric motor to do all the work for us. So the electric motor is driven by electricity from the mains. It provides nothing towards the charge on the sphere at all.
It's just turning that roller at the bottom.
That's right, it's just turning the roller. And the plastic belt running around that roller to a roller at the top is carrying the charge up and charging up the sphere at the top.
So it's gathering inside that sphere a lot of electrostatic charge?
Yes, it's charging the sphere up, and the charge actually gathers on the outside of the sphere, evenly distributed, and it builds up until there's sufficient voltage there for it to spark across to the ball.
And when it's got a large amount of charge, it's just cracking through the air. In fact, you can hear the sound of that, but in fact it's affecting our pictures as well, isn't it?
Yes, that's right.
Right, you've got a few more experiments there we can have a look at.
Well, the next one is a low voltage, a low pressure neon tube. That tube contains neon gas at less than atmospheric pressure, and the charge is actually going through that to Earth.
Every time that flashes across, it's going through the neon light. That's a neon light like you might see in the street,
Yes,
isn't it?
that's right.
Through to Earth. Right, what's the third one you've got?
The third one is a sort of bucket brigade where we have a series of little balls, all with conductive coatings on them. And because like charges repel and unlike charges attract, when those balls get charged up at one end, they carry the charge away to the other, dump the charge and come whizzing back because they're attracted back.
I see. So when they're at the opposite end and they've got rid of their charge, they're attracted again.
That's right.
And they come back.
Yes.
Yes. Now you've got a special one for us, haven't you? This is a special experiment.
Yes, I'll turn the platform round. This is Hamilton's mill, after the man who discovered it. And essentially it's just a wire mill with very sharply pointed ends.
And as soon as it comes near that sphere, it's turning quite fast, isn't it? You're
Yes.
going to give us a clue, though, aren't you, as to how it works?
Yes, I am indeed. But first I'm going to turn the machine off. And I'm going to do something else with this machine that certainly I wouldn't touch this sphere before I'd done it, and that is to earth it, because it still has quite a charge on it, and it would give me a very nasty jolt if I touched it without doing
So it's
that.
completely safe now?
Yes. And I've got a small pin here with some sticky tape, which I'm going to place just there. Right.
And that's where this candle comes into play, isn't it?
And turn the machine back on again, and we'll light the candle. And we'll see what happens. Yes, something's happening.
Yes, you can see it flickering. There's a movement going on there, isn't there? Now, that flickering candle is the clue. That gives you the clue as to why the mill was turning. This must be the simplest electric motor in the world. There it goes. Pretty good, eh? All you need is a few bits and pieces, just like this. Paul, how did you make it?
Well, the first thing we have to do is to take a polystyrene cup and cut the top out, like that. And if we make that shape, that means that you can put a battery in top and it holds it nice and steady.
Yeah.
Okay? So that's where we're going to get the power supply from.
Yeah.
The next thing we've got to make is the coil that spins round.
Yes, you need this wire for that. That's about a metre you've got there,
Yes, that's
isn't
about
it?
a metre length of wire. This is copper wire. It's enamelled copper wire, and it's 26 SWG.
Yeah.
And we have to wind that around something round. We're using a test tube here. We leave about 10 centimetres clear at one end and just start winding it round the test tube.
That SWG stands for nothing more important than standard wire gauge, doesn't it?
That's right. It tells you how thick the wire is. So once we've wound on enough so that we've got 10 centimetres, well, roughly 10 centimetres clear at the other end, we stop and then squeeze the coil up, and then keeping a firm grip on it with your fingers, otherwise it will all spring clear.
Yes, because you've made a very good spring.
Slide it off the tube, and then to keep the coil together we have to wrap the free ends around the coil.
Yeah.
So if you just pass the free end through the coil And then pass it through about twice, should be enough, and pull it quite tightly.
And that bit left over is what it's going to end up spinning on, isn't it?
That's right. So the two free ends are going to form the axle of the motor.
Yeah.
And then we take the other one round and pass that through.
And that end must be pretty well opposite the other end so that it'll spin freely.
That's right. If you don't line them up, then the coil won't spin true. It will be wobbly.
Yeah.
There we are.
Now, you're not going to get any electricity getting into that coil unless you get rid of some of that enamel, are you?
That's right, that's right. The enamel is a kind of varnish. It doesn't conduct electricity. So we have to use a piece of sandpaper to scrape the enamel off.
Yeah.
And you can tell when you've got the enamel off because I think you can see the nice shiny copper showing through.
That's a different colour, yes. Yeah.
Right. Well, the next thing we've got to do is to make the bearings. And we've got some more incredibly expensive apparatus here. We've got two paper clips.
Two paper clips, right.
Which we have to bend out.
Open it out.
Like this.
Well, when you open that out, you get a sort of an S shape, don't you?
That's right. And then at the smaller of the two ends, we then use a pair of pliers to bend that into an S shape as well.
Yeah.
So we bend that round. That's a bit tricky, but with a bit of practice.
There it goes. Right.
There we are. And then we've got to fix these to the two ends of the battery, and we're going to use an elastic band to do that. I'm using quite a big elastic band, and I'm going to use it doubled so that it makes a nice strong contact.
Yeah.
There we go.
Because the paper clip is going to be a means of getting the electricity from the battery into that coil that you made, isn't it?
That's right.
And so it's got to be a good strong contact.
So that's the negative end.
Yeah.
And then this one on the positive end. Make sure we get a good contact.
Yeah.
There we
They
are.
have to be about the same height.
Make sure that they're roughly about the same height. That's it. Okay, right, well, if you'd like to get your magnet...
We'll have a go.
We'll have a go.
Right. Here we go. Oh! There it goes. Another go. Oh, that's going very well. Yes. Well, the whole thing becomes even simpler if you can find a smaller magnet like this. It's a sort of squashed magnet, so the North and the South Pole are on the top and the bottom. That is the North Pole, and that is the South Pole underneath there. Now that will clip on to the metal battery there, and the whole thing will run by itself. There it goes. Magic.
What do you think's driving this little clock here? Well, you'd probably expect a battery, wouldn't you? But in fact, it's just two lemons. Well, it's not far away from a battery, though, because if you look at this lemon, you'll see it's got a copper probe sticking into it. If I pull it out, the display goes off. Put it back in. And there's a zinc probe. There we go, like that. Now, what happens is when you've got the two different metals inside the lemon, the chemicals inside the lemon cause a small electric current to be able to flow from these probes. In fact, two lemons, as you can see, quite happily drives a clock. Moving along, two oranges, he's driving a thermometer here. Another device here with two potatoes, a pineapple, this is my favourite one. The avocado and tomato thermometer, there you go, why not? This is cola. Look, if I take that one out of the drink there, you can see the display flickers and put it back in. There it goes. You can use beer if you like, but it's a bit of a waste. And here we have two pot plants busy happily working something over there. In fact, almost anything works apart from distilled water, but don't worry about that. Now, consider this. Here we have a sheet of aluminium and a sheet of copper, both wired up to a meter like this. Now, if I put my hands on here, you see what happens to the meter. Take my hands away again, and there we are. That shows us a small current flowing there. So ask yourselves, what's replacing the lemon?
You may have seen this sort of equipment before. It's called a gold leaf electroscope, and this is how it works. I'm going to try and put a bit of electric charge on this polythene, and as I bring it close to the electroscope, you can see the gold leaf rising to show that there is an electric charge. Now, of course, that equipment is really quite expensive. After all, it's got gold in it. But you can make a simpler version out of, believe it or not, an old baked bean can, once you take the label off. And to show us how to do it is Paul. Paul, how did you make this?
Right, well, here we have an old baked bean can, and the first thing we have to do is to make sure that it's insulated from the bench. And we're going to use a polystyrene cup, which is a very, very good insulator.
Yeah.
So we then stand the tin on the polystyrene cup. But the next thing we have to do, we have to fix strips of tissue paper to the sides of the can.
And that'll take the place of the gold leaf, will it?
That's right, that's right.
A bit cheaper.
It's also cheaper, that's right. And we've got to make sure that the pieces of tissue paper are free to swing. So what I've done is I've got 2 pieces of wire and just bent the wire like this, passed the tissue paper around and fixed the free end with some sellotape.
Yeah.
And then to fix it to the can, I've got 2 small pieces of plasticine or blue tack and just push the wire into the plasticine and just make sure that it's free to swing.
Okay.
Now,
Right. Shall we have a test of it then?
Yeah, there we are. I've got a polythene bottle here. And we'll give it a few rubs of a cloth.
Oh, that's very good. There's obviously a charge there. Do you know whether it's negative or positive?
Well, polythene produces a negative charge.
Yeah. Well,
So perhaps you'd like to earth it now with
I'm
your
getting
finger.
rid of that charge there.
Yes, you're obviously a very good conductor. And now, watch what happens when I take the bottle out.
Ah, it's now got another charge on it.
That's right. It's now, we've induced a positive charge onto the pieces of tissue.
We could prove that by putting another negative charge next to it, couldn't we?
That's right. We've got another canalletoscope that we've made. And I'll charge this one up like we did previously.
Right, so that's
So
a
that's
negative charge there.
And now try bringing the 2 together and see what happens.
And bring it next to the positive charge, and opposites attract. There. Well, you can use your electroscope to test all kinds of plastics, see whether they charge positively or negatively. How about a polystyrene cup, for instance? What sort of charge can you get on that? And of course, you could try something like the old favourite of a balloon. And does it make a difference what you rub it with?
We know that flames can do some fairly unusual things. Well, to show us one more, we've got Steve. What are you going to do this time?
Well, a flame will actually conduct electricity. And I can demonstrate that with this apparatus I've got here. First of all, we've got a probe, which is connected to a battery. The circuit goes through a meter and to the base of this Bunsen burner. And all I have to do to complete the circuit is to put the probe into the flame. And you can see a current flows. If I take it out of the flame, the current ceases.
They put me on here to prove that making electricity is literally hard work. And I believe them.